A Finnish town just built the world's largest sand battery, and it could solve renewable energy's biggest problem for under $25 per kilowatt-hour. A small Finnish town has built something that could change how the entire world stores renewable energy. Standing at 13 meters tall and 15 meters wide, the world's largest commercial sand battery is now powering 5,000 residents with clean heat, and it cost less than $25 per kilowatt-hour to build. Compare that to around $115 for leading lithium-ion batteries, and you can see why energy experts are taking notice. This is not a prototype sitting in a lab. This is a real, operating facility doing real work for a real community, and the implications go far beyond Finland's borders. The renewable energy transition has a well-known Achilles heel: intermittency. The sun does not always shine and the wind does not always blow. To make renewables reliable, we need massive amounts of energy storage, and that is exactly where things get complicated. Current solutions lean heavily on lithium-ion batteries, which are costly, depend on critical minerals, and come with their own supply chain vulnerabilities. Tommi Ironen, CEO of Polar Night Energy, put it bluntly in an interview with CNBC. "We are changing from a world where big power plants do the energy production to one where solar and wind are producing the energy, and that requires a massive amount of storage. The question is, what kind of storage?" The answer in Pornainen is surprisingly simple: sand, or more precisely, 2,000 metric tons of crushed soapstone. The system works by using excess electricity from the grid to heat the stone pile up to several hundred degrees Celsius. That heat is then stored in an insulated container for days or even weeks, and released when the community needs it. One commenter on the original Reddit post pointed out an important distinction. This stores thermal energy, not electrical energy. That matters because if you are using the thermal energy directly for heating, you get up to 90% efficiency. But if you convert that heat back to electricity, efficiency drops to about 45%. For district heating systems, that 9 in 10 figure is transformative. The results in Pornainen are already impressive. According to the CNBC report, the facility can cover almost 1 month of the town's heating demands in the summer and roughly 1 week in the winter. That is enough heat for all 5,000 residents. Since launching last year, Polar Night Energy estimates the project has slashed greenhouse gas emissions from the local heating network by almost 70% and reduced the use of wood chips by about 60%. An existing wood chip power plant remains in operation as a backup and peak load facility, meaning the town gets the best of both worlds. Clean sand battery energy for the majority of the year, with proven thermal capacity on standby when demand spikes. One of the most compelling aspects of this technology is what it does not need. No rare earth materials, no critical minerals, no exotic components that tie energy storage to geopolitical supply chains. The CEO of Polar Night Energy told CNBC that hopefully a big portion of future storages could be sand battery type, where we do not need rare earth materials. The materials used are locally sourced and fully recyclable. The units are also designed to be scalable and modular, meaning they can fit everything from small towns like Pornainen to large-scale industrial applications. There are no geographic requirements, and because the core material is abundant, there are no supply issues driven by international tensions or trade restrictions. A commenter named Vi Fate raised an excellent point about the physics of heat storage, and it explains why size is not just convenient but essential. Heat loss is a function of surface area, which scales with the square of the dimension. Heat capacity, on the other hand, is a function of volume, which scales cubically. That means as a system gets bigger, its volume grows much faster than its surface area, so a larger system loses heat proportionally much less. A 10-meter cube has a volume to surface area ratio of 67%, while a 5-meter cube is only 33%. Another commenter noted that ideally the shape would be a sphere for maximum efficiency, though as one quipped, it is a lot harder to build a sphere than a cylinder. This is not even the first time sand-based thermal storage has worked in the real world. A commenter named Barton 2800 pointed out that near Calgary in Canada, a community of about 50 houses used a large sand-filled reservoir underground, charged by solar heating. combined with high-efficiency construction and large solar installations, that community got almost all its heating, 97%, without any fuel or grid power for the entire winter. The optimal community size was estimated at 300 homes, but because the region was not willing to invest, the system was decommissioned and replaced with natural gas furnaces a couple of years ago. It ran more than 4 times longer than its original 4-year design life, which a commenter called heroic, only to be torn out for a conventional alternative. Pornainen sand battery proves that renewable energy storage does not have to be expensive, exotic, or geopolitically fragile. It works today, it works at scale, and it works with materials you could find anywhere. As solar and wind continue to dominate new energy capacity worldwide, technologies like this that offer cheap, abundant, and modular storage will move from novelty to necessity. Finland is showing the world how it is done, and if this model scales, the implications for the global energy transition could be enormous. Thanks for watching, and if you want more deep dives into the technologies reshaping our future, make sure to subscribe. Pornainen sand battery proves that renewable energy storage does not have to be expensive, exotic, or geopolitically fragile. It works today, it works at scale, and it works with materials you could find anywhere. As solar and wind continue to dominate new energy capacity worldwide, technologies like this that offer cheap, abundant, and modular storage will move from novelty to necessity. Finland is showing the world how it is done, and if this model scales, the implications for the global energy transition could be enormous. Thanks for watching, and if you want more deep dives into the technologies reshaping our future, make sure to subscribe.